Welcome back to my channel, Form 4 Physics, topic Heat, Lesson 10. We continue with the objective questions. Number 3. Liquids R, S, Tu are of the same mass. So all the liquids same mass and have the same initial temperature of 20 degrees Celsius. So these two information we should collect. The mass is same and all the initial temperature, I put Ti, the I stands for initial, is the same. We are doing step 1, collecting what is given. If heat is provided at the same rate to every liquid, rate, so now not heat but rate of heat. The rate of heat is the same for all the liquids. We see what is the question asking. Which liquid is the first to boil? Which liquid is the first to boil? So they are asking which liquid first to boil. We always start from what they ask. Here, first to boil, of course it means which one takes the lowest time to boil. First to boil meaning which one will take the shortest time or the minimum time to boil. The minimum time to boil. Okay, and boil, from here, boil, that means the liquid must reach its boiling point. Then only it will boil. So we always start from what they ask. So first to boil, first here would mean which one takes the minimum time, and boil means which one reaches the boiling point. So basically the question is asking, of all the 4 liquids, which one will reach the boiling point at the minimum time? And the initial temperature was 20. Okay? If you look at the diagram, look at all the boiling point, 70, 100, 110, 120. So all the boiling points are higher than the initial temperature, which means from initial temperature to reach the boiling point, this means the temperature must rise. And for the temperature to rise, that means there's a change in temperature. From 20 degrees Celsius, initial temperature, it must rise to reach the boiling point temperature. There's a change in temperature. Because there's a change in temperature, which means the heat involved now, of course, will be Q equals to mc theta, involving the specific heat capacity. Okay, we already learned from the notes, heat involved in the change of temperature is capacity heat, and the total heat will be mc theta. The small c, specific heat capacity. Now here, we are given heat, the total heat. But the question has given us, the rate of heat is same. The rate of heat is the same. Now the word rate means anything that occurs in 1 second per unit time. Anything that occurs in 1 second. Which means this total heat must be the rate of heat, I put Q, times by the T time, which is mc theta. Of course, basically on maths, if I want to find the rate of A, it must be the total A divided by time. This is maths, Form 1, Form 2 math, rate, ratio, proportion. To find the rate of A can be anything. It must be the total A divided by time. Here, so the rate of heat must be the total heat divided by time, which means the total heat, I take the time, I transfer the other side, it must be the rate of heat multiplied by the time. I put this in brackets. So that's how I got this. And this question is telling all the liquids have the same mass and the same rate. So they have the same rate and the same mass. So these two is not involved in the working. It's not involved in the working, which means the time for it to boil only depends on the specific heat capacity and the change in temperature. It is not equal. So now the time, it is dependent on the mass, depends on the specific heat capacity, C, and the change in temperature. So time to boil only depends on the product of specific heat capacity times the change in temperature. So in order to get the minimum time, we need the minimum product of this. The minimum product of this, which means the C and theta, we have to calculate the C and theta for each one. Keep in mind here is change in temperature. We were given the boiling point. So this theta, I put back. This theta would be change in temperature, which is the boiling point higher minus the initial temperature 20, which was lower. So that's what we have to do. We have to do this. We want to get the minimum time, we need the minimum value of the C theta. So we have to do this one by one. For the first one, C, 600, it was 600 times boiling point minus T1. The boiling point was 70. 70 minus 20, that would be 50. Okay, later I do this calculation. So we repeat this for all the four liquids. The next one is 4,200. 4,200 times the difference in temperature. Boiling point minus initial temperature 100 minus 20, that would be 80. Third one would be 200. Third one is 200 times, again, change in temperature, 110 minus 20, that is 90. And finally, the C 200. The C 200 times 120 times 20, 100. That's all. So you have to do for all four. So all we have to do now, find the one that gives the minimum product. Of course, 4,000, this is not a big number. This one will give us 6 times 5 is 30. That is 30,000. 9 times 2 is 18. 18,000. This is 2. We have the 4 zeros. 20,000. This one no need to count, already very big already. So if you look at all three, this is already big. That's why I'm not doing the calculation. The minimum value is the 18,000, the third one. So this gives, the third one gives the minimum value of this. Therefore the minimum time, which means our answer is the third one, C. The liquid T. Okay, that is the answer for question number 3. It is an extremely good question. The next question I will do in the next lesson.